So with that, we are finished basically with the, let's say, theory part. And I would say, let's jump into the basic operation of the system. And I will hand over again to Antonia.
So I think you can hear me now. So let's go on with the basic operation of the Bravo handheld spectrometer. And the following slides that you will see, they are basically just an excerpt of the Bravo basic training presentation and user manuals, which you are very welcome then to have a look at after the service training, and we will provide them for you. So I would say let's have now a closer look at the Bravo device itself. I think we will do that simultaneously with a presentation and with having a look at the Bravo on camera. I think you can see Felix now. So basically what we have is a position for our measuring tip. Typically the Bravo is coming with a back tip or a vial tip using polystyrene samples for daily PQ testing. And what we also have on our device is a large 7-inch touchscreen here for operation of the workflows, which I will show you in detail just in a few minutes. What we also have on the Bravo is the keypad, including different buttons that you can push. We, for example, have the on-off button here on the very lower left. You can just turn on and turn off the Bravo device. You can also switch on and off the laser with the red button. And then in industry, it's often very good to have a barcode scanner to quickly get the information of the material that you want to have a look at. And on the right, upper right here, we have a start measurement button. And then on the very bottom of the Bravo device itself, there is a battery door to exchange the batteries. And it's quite easy. You have seen you just quickly detach it. So quite handy to use. The batteries that we use are lithium-ion batteries. And just for the opening, open it counterclockwise, otherwise it won't work. And the charge status of the batteries itself is shown on screen on the Bravo device, on the touch screen, here on the upper panel, shown or indicated with a battery symbol. Green shows full green loaded battery shows you that it's loaded. And on the right side on the presentation, you could see you can also check the charge status on battery. And if it does not have any charge anymore, you will see the black squares vanish. Then, also quite important, we offer different measuring tips for the Bravo. And first of all, I would just quickly say the best spectrum quality can be obtained by optimal sample positioning in front of the tips or inside of the tips. I will show you that later. And another thing which is really important is the blocking of external light. Otherwise, it will overlay your spectrum. And as if you just remember, the Raman signals are very weak. So this is something that we really want to avoid. Bruker also offers custom-made inserts and tip design. So this is also very cool. And if you have contact with customers, make this clear. It's, I think, quite good. Then the standard tip, I would say, is the back tip, often used in industry to measure through packaging foils. And if you have a closer look on the right side, you can also, for example, use the back tip a little differently and position your sample on cover glass. Here we have pigments or dyes that we just want to measure. But have a look at this point. So we really should avoid external light. And for such measurements, it is recommended to additionally use a light shield to block the external light, and then you can obtain very good spectra for pigments, for example, in art and restoration. Then we also have variable focus tips, or a set with fixed focus tips at different distances ranging from 1 to 4 millimeter. And those variable focus tips are really important, for example, in art and restoration, because we want to avoid direct contact with the sample. With the back tip, you usually should really have direct contact with the sample, but in art and restoration, you want to avoid that, to avoid scratches or just damage of the sample or the paintings. Then we also offer a vial tip, which is actually used for the PQ testing or OQ testing, usually with polystyrene and calcite sample. You can see the polystyrene sample here inserted into the vial tip. You can measure all kinds of samples, typically liquids, but also solids filled in glass or powders. It's also possible. The glass vials can range in diameter from 3 to 13 millimeters. In case you have pills, tablets, or even powder samples, you can use a magnetic measuring tip, which is quite easily applicable. You can position the sample inside and then just close the lid. And it will just, make space for the pills inside. And another thing, this aluminum cup is very good for powder samples in case you only have a low amount of your sample available. Then we will come to the good measurement practice. First of all, you have to make sure to use the proper tip for the application. So if you have a liquid, the back tip is maybe not the right choice. So make the right choice for your application. Secondly, as I mentioned before, typically you should ensure direct contact to the sample using a back tip. Thirdly, avoid influence of external light sources. And fourthly, avoid sample movement during measurement, and 0.5 is quite same. So you should avoid sample movement and also remain in contact with the sample during the whole measurement process. And then with this, you can obtain very good spectra. And I think with this, I can now switch to the Bravo GUI on the other computer.
So we quickly need to change our setup here. Just one moment. So I share my screen now. So let's see how this does look like. Perfect. You shall see now all the graphical user interface of the Bravo with the login screen.
I think now you can hear me again. Let's have a closer look now at the Bravo GUI. So how it looks like when you actually turn on the device. So first of all, what you will see and face is a login screen. And on the bottom, on the top left, you can see the Bruker. On the top left, you can see the Bruker symbol. On the top right, you can see the time. And in the middle, you can see the login screen with the field for user and password inserts. You can get access onto the Bravo either by just clicking onto the user field and then typing in, for example, the user that you want, or you can have a look at the list of available users. Let's just say I want to be an admin today. Then I will type in the password, which is typically Opus in our case with capital letters. I press enter and voila, we enter the Bravo. So, but as easy as that, you can also just quickly log out by pushing this button and enter the first screen again. You can log in as admin again, pushing this admin symbol or user symbol and type in the password in this case. And let's just enter Bravo again. So what do we see here? On the top, you typically next to the time also see the charge status. I think you can see it on the video. And you can see some connection symbols that Felix will come to later in more detail. Then what you can see on the bottom, on the left, is, for example, the OVP status. And I think we will talk a little bit about that later as well. You can see the required PQ or OQ testings, whether they are valid, and the validation or valid date until they are valid, actually. Another thing is you can also have a look at notifications, which I will maybe show you like this. An easy mistake that is often being done during measurement is you start a measurement without the laser to be turned on or enabled, just by simply forgetting to push the laser on button. And as you can see in the camera now, there's a red symbol here, which is typically on this nail symbol. You can click on this and then have a look at the message, and you can also remove it if you don't want to see it again. So then I would say let's get started with the workflows here in the middle. I would say let's get started with the most commonly used one in industry, which is the verification. So in the verification mode, you typically know what you want to see. Let's just say you have in my case, it's polystyrol or polystyrene. But let's just say when you're in industry, you have acetaminophen, which is also known as paracetamol. And just for the clarification of these fields, in the material field, you typically type in a unique name for the material that you want to have a look at. In the compound name, typically you write in the name of the material in a more general way. Let's just say acetaminophen is the same as paracetamol. Then you just use acetaminophen. But if you have different suppliers, which often is the case for lab applications, you just type in different supplier names in the material name, or for example, list numbers. And let's keep it simple now. I know that the sample that we have in this case in our service training today should be polystyrene, as you can see in the video. So I just use it here. I push the next button, and then you can see you should position your sample into the tip. If the tip is not attached, Bravo will tell you that. And then you just need to attach the tip again, and then you are able to start a measurement. What you can see on screen typically is the measurement progress or procedure that I will come to after introducing you the GUI. After measurement, Bravo tells you whether the polystyrene sample is really polystyrene and matches, and you get an accepted. In case of a fail result, it will tell you that. We can maybe quickly do that as well. Let's just say I use another, let's say acetaminophen, as I've just said before. I just say I expect acetaminophen. I start to measure. And probably we will not end up with an accepted now. Yes, we will end up with a rejected result. And Bravo tells you, okay, you think it's acetaminophen. It is not. It will show you the library that it used to search whether it can find any spectra matching. And it tells you the hit quality is quite low. The hit quality itself is a correlation. So typically a Pearson coefficient ranging from 0 to 1. 0 means very bad match, and 1 means a very perfect match. So the hit quality of 0.00 is really bad. But Bravo suggests you, hey, there might be a possible other match. The material could be polystyrene, and the hit quality of this one is 0.996, which is pretty good. Then you can press here and have a look at the spectrum. Here in white, you can see the sample spectrum that you just measured. In red, you see the acetaminophen that you type in and said, oh, I expect acetaminophen, but you see it does not really match. And on the very top, you can see the suggestion coming from Bravo. You can also have a look at the different spectra itself, click on them, change their position, and you can also zoom in. For example, have a closer look at different bands and say, okay, maybe I want to have a look at this band here, or I can see maybe like 2 peaks quite close to each other. And then you can also zoom out. And if you just think, oh, I think I screw this up, you can also rescale. You can click on series just to measure the same workflow again with the same information, or you could have just clicked next to perform a very new verification. Then what you can also do, which is really useful in industry, you can scan barcodes just to make the whole procedure more time efficient. The material name and batch name will fill up by themselves if you set the correct scan code format for the Bravo. Then I would say we quickly have a look at the bottom right on the GUI, 3 dots, because we are now in the verification workflow with the 3 dots. What you can do is have a look at all open workflows. And you can direct to home and also click again on the 3 dots and direct directly back to the verification workflow. This is quite good. So you can see what is already open, and the information is also saved in the workflow. Let's say I just want to go back and start another identification workflow. I can type something in and click on the 3 dots, go back to verification, and I'm still seeing the same information that I had before. It's quite practical. But now let's close the verification and just go back to the next workflow that I want to show you, the identification, which is, for example, used in art and restoration. If you want to know how can I actually restore the dyes, I just want to know what kind of dyes the artist used, then you can just type in, let's say, dye 1. Another thing that you can set here is the delay time. Let's say you want to run away from your Bravo for whatever reasons before measurement. You can say, okay, start a measurement in 2 seconds. Or maybe the sample is not well positioned. So you just say, wait 2 seconds before you start a measurement. In case you want to give more information for the sample, you can do that by clicking more. You can add, for example, the batch information and container information. The batch information is typically the information of samples that has been produced in the same procedure, and the container just tells you like which container it was or which vial it was in that batch. But we don't need that. We just have a dye in this case. We click next, but the dye is actually polystyrene. But let's skip that. We will start the identification measurement. Or we just think it's a dye, let's say that, and then Bravo will tell us, well, it's not. And it says, oh, it's polystyrene. It's actually not a dye, it's something else, but it identified our material. And the hit quality, same as before, is 0.9961. You can have a look now at the hit list, which is also quite useful in the identification workflow, because it tells you, okay, Bravo thinks the polystyrene spectrum matches the best to polystyrene, which should be the case, but there are other spectra which are matching quite well. for example, benzyl alcohol. But if you have a basic understanding of these correlation values, 0.92 is not as good as 0.99. And there are other hits shown, but with decreasing hit quality. Now you can, for example, say, I want to have a look at the different spectra here. You can select them, select all, or just go to the spectra that you just selected and just have a closer look how well they actually match the spectrum of your sample. And you can see the white spectrum matches really well with the polystyrene, but we have to say it also matches pretty well with benzyl alcohol, but just not as well as with polystyrene in this case. You can then zoom in again. As Felix shows, you can also, with the touchscreen, easily overlay the spectra on the webcam and also rescale them easily. And the color coding is quite nice because it makes the overview quite comfortable. Then you can push next, perform a next measurement, or just go back to the results again, or we just can close it and go over to the next workflow, which would be acquire material, which is also a quite useful workflow. In acquire material, what you can set is the material name, compound name, barcode, badge, and container, as you have seen before. Let's just say we have material A, compound B. These are necessary before the next button appears. Without entering a material and compound name, you cannot go to the measurement section. Then we have entered material name and compound name. We can go and type in next and start a measurement. So this is actually just a workflow to acquire spectra, but not with the purpose to identify the material. And this is actually quite useful to making your own libraries. You can just measure some material that you know and say, okay, I don't have the spectrum as a library yet, but I can measure it and say, this is my reference that I will use in the future. And for example, if the sample is degrading or changing over time, you can see it having always a look at the reference spectrum that you measured via acquired material. Then I would say I will first click to archive. You can see the spectra that you just measured before, select them. You can open them again. You will just see the same screen as before, or the information screen. And you can go back to the archive, have a look at the identified results. You can have a look at the verifications and see also the rejected acetaminophen. You can, in this case now, select them by hand or just push the select all button and remove them in this case. But in the validated system, this is a little different. I think Felix will say something about that later. And in the archive, you typically can also have a look at all the available libraries on Bravo. Then let's go back now to the main screen, the home screen, and have a look at the settings. First of all, we have a system button. And in the system button, you can see the current software version on the Bravo. And it also tells you then whether you might need an update of this software. Then the software and firmware is separated by spectrometer button. In the spectrometer field, you can see now the firmware version and also the serial number of the Bravo, which is typically in this format, BRV, and then we have 5 numbers. Then you can go to the acquire material settings, and this is quite important when you want to make a library entry. Bravo only accepts spectra which are measured in the full range for Bravo, ranging from 300 to 3200 wave numbers. If you now decide to change this spectrum region, from 300 to, let's say, 500 wave numbers for whatever reason. You can measure and acquire the spectrum for your material, but you can't use it as a library entry. But you can also disable this button and just not use a custom spectral range. In the identification workflow, you can also have different settings. In this case, you can say, okay, I have different libraries available, but I don't want to select them. Then Bravo can't identify your material. But you can say, I expect a solid, so I will only select the Bravo solid library and then perform my identification. There's a possibility to define more parameters for identification. For example, the hit quality threshold. You can set it, for example, higher, which will reduce the number of hits displayed later. Or you can set it really low. This depends on what you want to see later. The number of hits can also be reduced manually before identification. With this button, you can just decrease it and say, I just want to see the top 3. Then you can just display the top 3. You could also say, okay, I want to identify this material, but I know it's contaminated with something which is showing high signal in a certain spectral range, which I want to avoid. So you can just say, I want to focus on a custom spectral range from 300 to 1800 in this case. And these are the settings for identification. Let's go to verification, which is a little simpler, because in the verification, you already know what kind of material you expect, and you just want to verify whether polystyrene is polystyrene or acetaminophen is acetaminophen. So you already know which library you want to select, and you can only select one library, which makes sense because you know what kind of material you are facing. Then I think we are done with this settings screen. And I think I would go on maybe to the presentation here.
Yeah, okay, I can take over as well.
Oh, like that, yeah. Maybe mute me here.
Super, and I hope you can hear me now. I can share the screen again. Let you see our presentation. Looks good. Okay, perfect. So thanks, Antonia, for presenting the workflow on board of the Bravo instrument. I think we haven't forgotten too much or anything. Perhaps the date, if you wonder where the date is. So because here in the top of the screen, you only have the time. There wasn't enough space for the date in order it looks pretty. So we put the date. If you go to this switch screen functionality, you see the date here in the bottom. So perhaps this is something to add, because customers, especially in pharma, always ask for timestamps, and they always want to have a look at the date and time if this is correct. Okay, the measurement, let's say, sequence and process, how this is working, especially for you as service, I think it's very good to understand what's happening on the instrument. So if you enter the workflow, for example, for acquire material, verification, or identification, there's already something happening prior you start the measurement. Our detector is not working at room temperature, or this would be even bad because internal of the Bravo, it could get quite hot. And this is not good for the detector noise. So we have an actively cooled detector. And of course, we don't cool the detector all the time because it's battery operated. And the detector cooling is one of the main consumers, power consumers. And so we only cool the detector if this is required. So in order that the user is not sitting there and waiting for the detector to be cooled down, we already start the cooling if a user enters a measurement workflow. If he's pretty fast and starts a measurement straight away, you will see that there's a progress bar for prepare measurement. So, but if the detector is already cooled, which typically takes between 10 and 30 seconds, depending, of course, on the internal temperature of the Bravo. And if it's already pre-cooled, it will be directly finished with this check mark. So then what's happening that the Bravo is taking a survey scan, which is, let's say, a basic measurement with a standard scan time of 750 milliseconds per laser excitation. This process overall takes around 10 seconds, and then the Bravo is evaluating the result. During this, let's say, survey scan, the Bravo first makes a background measurement, so basically a dark spectrum with the laser switched off. So here we would measure, for example, disturbing surrounding light, which enters the spectrometer. After this scan, we switch on laser 1, measure 750 milliseconds with laser 1. Then we switch to the second laser with 852 nanometers. Then we change our diode temperatures. So as well, the lasers are temperature controlled. And we change the laser emission by controlling precisely the laser temperature. So we switch from temperature 1, which is already stabilized prior measurement. We switch to temperature 2. Again, measure with laser 1, measure with laser 2. So the switching is very fast. This takes only a few milliseconds, whereas changing the laser temperatures takes a couple of 100 milliseconds, of course, with control mechanisms which confirm that the temperature is stable and at the correct values. So again, with laser temperature number 3, we measure 2 spectra with both lasers. So now we have for laser 1 and 2 our 3 spectra, which we need for SSE. So then there's data evaluation, meaning we are separating the fluorescence, evaluating then the Raman signals, and check if the detector signal is already intense enough. If yes, we are fine and doing the evaluation in matching the data to the library data. If the intensity isn't sufficient, the instrument will perform automatically additional scans, which we call co-additions, which are later on added to the survey scan. And the duration of this co-additions, or as well number of co-additions, is calculated based on the information which we generated in this survey scan. I mentioned that it could be as well multiple co-addition, not only a single one, because we are considering as well the intensity of fluorescent signals. And it might be, of course, that there's a detector saturation prior we are reaching our desired Raman intensity. And in order not to saturate the detector, we're then splitting the measurement in several individual measurements, avoiding detector overload. There's as well an option that the 750 milliseconds are already too long. Of course, in this case, the Bravo detects this and will automatically reduce the scan time for the survey scan. So that's it basically, how the Bravo is working, the measurement progress. And of course, if you see as a service technician, the prepare measurement is super, this is working, but acquiring survey scan, here I get a problem. Our LED, for example, is during the background measurement, it's blue, and it only switches to red. So the status LED on the Bravo instrument, and it only switches to red then when there's actual laser emissions. And of course, you as a service technician, that you do then know if the service scan is starting, but then it's dark, the laser diodes are not the LEDs not getting red yet, then you know, okay, the lasers are not switching on. Because perhaps I need to emphasize this, the hard key button on the instrument here only switches on power supply basically of the laser. It is not that we have laser emission if this is blue. And it's not influencing the laser lifetime if this is blue. Basically, it's like you have your notebook plugged into the power socket and it's off. Only if it's red, the laser is actually switched on by our software. And of course, this is only possible if the power supply basically is active. So far for the measurement process, and it's complete identically for all workflows. Perhaps at that point, there is no possibility for influence for any operator. So the evaluation parameters, they're all set in the library. So on board of the instrument, as you've seen, it's really super simple, the workflow. So I think we are pretty much done with this part, and the time, I think it's already 9 o'clock has passed. So I think let's make a short break around. There's one question. Okay, perfect.
Password.
What? Okay, perhaps we come to this later, but I can tell you, passwords, especially administrator passwords, shall not be lost. Of course, if you lose your password from your, let's say, personal computer or something like this, you need your IT to reset it. So in this case, there is no IT administrating the Bravo operating system underneath. So if the administrator password is lost, it's lost. And basically, we as Bruker, you as service technician, are not authorized to access customer data without access authentication. And that's basically a rule set which is given as well by the pharmaceutical guidelines. So you only can access the data after successful authentication. So lost password is lost password. In order to make our users sensitive to this topic, we in the meanwhile supply an information sheet at Bravo deliveries with the instrument, and we are pointing out that we do recommend that the system owner, so the customer, generates, for example, a backup administrator IT/service system account, which is, for example, not personalized, which is stored by IT, which can be used to recover all accounts independent on user role. If, for example, an operator, no matter if it's an administrator, user, lab manager, or basic operator, did lose his password. So of course, there are still some possibilities for us as headquarter to access the system with special tools. But basically, lost password is lost password. And what you as service technicians need to do then in the field, open the Bravo instrument, basically. You will see this tomorrow. And we need to exchange the complete memory because we don't have access to the memory without password via the Bravo software. So especially pharmaceutical companies where data integrity is important, they must not lose their passwords. In Opus, this is complete identical. Of course, if an administrator lost, or all administrators lost their password, they can still, an administrator, Windows administrator, can delete the Opus database file. But then you will start from scratch with a new user database. You've lost all information on the global audit trail and everything. So this would be for a pharmaceutical company a disaster. And it's very important that there's always a password, an administrator password existing. And of course, best is if the IT sets up a service account for safety reason, which is stored at a safe location, which is not handed to any individual, and which can be used to unlock accounts in the worst case. So that's all questions. Perfect. Then I would say let's have a break around 10 minutes, let's say. I think this is appropriate. And then we'll be back soon. We'll leave the meeting open just mute ourselves.